Welcome, Hornets, and thank you for joining me today. Today we are working on finishing, at least doing part three of the classwork assignment, assignment number 12. And this is found on page 453. And we are currently working on numbers 15. And I am doing 15 through 22 still. So I'm currently just doing the odd problems, although I did do the first, I think, 10 problems, 11 problems in their entirety. So beware if you have issues, please go back and look at those. So in number 15, which was the next problem on our list, we are being asked to rotate around y equals 4, and we are given the equation y equals x, y equals 3, and x equals 0. So the first thing that I'm going to want to do is graph this. And we have this y equals x, which is fairly easy. We have x equals 0. That's going up, down. And then we have this line cutting across at y equals 3. And we're rotating around the line up here, y equals 4. So the representative rectangle we're looking at is sitting right there. And we've got two lines, our big R and our little r. The little r is going to have this endpoint. So this is x comma 4, x comma 3, x comma x. So my big R of x is, let's make sure I have that down. That was 4. So I have 4 minus x. That's my big R. My little r is 4 minus 3, which is just 1. Putting this into the formula, going from 0 up to 3. Making sure I have pi multiplied in front. I have 4 minus x, the quantity squared, minus 1 squared, dx. This is giving me 16 minus 1 is 15, minus 8x, plus x squared. Integration 0 to 3, multiplied by pi. I'm going to end up getting pi 1/3 x cubed minus 4x squared plus 15x from 0 to 3. This is giving me 9 minus 36 plus 45 multiplied by pi, and my answer is 18 pi. Let's go ahead and move to number 17 next. 17 gives me y equals 3 over 1 plus x. I have y equals 0. I have x equals 0. And I have x equals 3. So I'm going to make sure that I go through and I graph this one. Here we go. This is a reciprocal function. We can see that. It's going to have, let's see, what's my y-intercept? When x is 0, I have 3. And as this grows and grows and grows, it gets closer and closer to infinity. I am looking at rotating around the line y equals 4. That's up here still. So here's my representative x. I have a big R. I have a little r. This top value is x comma 4. Value down here is x comma 0. Value here is x comma 3 over 1 plus x. So I have my big R of x, and that's 4 minus 0, which is just 4. little r of x is going to be 4 minus 3 over 1 plus x, and we'll have to get a common denominator for that. So just be aware. So here we go. Let's get this cleaned up. Let's call this 1 plus x, 1 plus x. That's 4 minus 3 is 1 minus, let's see, 1 plus 4x all over 1 plus x. Make sure we have this r of x squared. And it's being subtracted from 4 squared dx integrated. And we are working on the integration. Let's see, this looks like it's 0 to 3 because our line is right here at x equals 3. So we're going from 0 to 3 multiplying by pi. Alrighty, so this is what we have to work with now. It's a matter of just trying to clean this up. We can clearly see that this one's going to be a natural log. Let's see what we can do with this. Maybe we can get it into a nice clean common denominator. I would hope so. So I'm just going to try and clean this up a little bit. So I have 16. We're going to multiply by 1 plus x over 1 plus x. That's going to allow me to have a minus 1 minus 4x. Ooh, wait a minute. Wait just a minute. Oh, alas, we're going to have to FOIL that out if we want to, or we have to start back at that one. So I'm going to have to just kind of square it. So that means that I have 1 plus x, the quantity squared, and that's going to now be a squared. And we're subtracting 1 plus 8x plus 16x squared. So this is 1 plus 2x plus x squared. So I have 16 plus 32x plus 16x squared minus 1 minus 8x minus 16x squared. Those are going to cancel. I have 15 minus plus, what's that going to be? 24x, and this is all over 1 plus x, the quantity squared. And that's what I'm going to integrate from 0 to 3 multiplied by pi. Alrighty, so we're just going to have to kind of clean this up. Let's see if I use a u sub. Can I use a u sub? Well, this is x squared plus 2x plus 1. And if I use this as my u equals, du is going to end up 2x plus 2, which is 2 times x plus 1. Let's see, I'd have to add 9 and then subtract 9. That would allow me to use the u sub, so I could have pi. So I'm completing the square in order to be able to do this. So I have pi, and I'm looking at factoring that 24 out, so that I have x plus 1. And that means that I can have a 12 pi multiplied by 2 times x plus 1 dx. And this would be over the x squared plus 2x plus 1. Now keep in mind, we still have that minus, and we have a pi, and we have 9 over x plus 1, the quantity squared, integrated 0 to 1 dx. And that would allow me to have 12 pi integrated 0 to 3 of 1 over u du, which is giving me 12 pi natural log of this x plus 1, the quantity squared, which would be outside, so we could make that a 2 here, minus u sub, so this is going to be negative 1 over u times 9 plus my c, and we don't need that because this is from 0 to 3, 0 to 3, 0 to 3. Let's put in our x plus 1 now. 0 to 3, get rid of that. Alrighty, now we're ready to go ahead and begin. So this is giving me 24 pi natural log of 4 plus, that's 0, so we take that away. Then we have, what is that, 9 fourths, so we're subtracting 9 fourths minus 9 wholes, so double negative. Let's get that to be 36 fourths minus 9 fourths is 27 fourths. And I now have an answer of 24 pi natural log of 4 plus 27 fourths. Now I can make this into, hang on, that should be a minus 27 fourths. Let's just make sure, plus 9 fourths minus 9 fourths minus the 9. That is going to be a minus 24 sevenths, 27 fourths, excuse me. And it is multiplied by pi. And that would be my answer that I would be looking for. You'll notice these can get quite complex. Using the calculator would make it go a whole lot faster. We find that it's about 83.317 something, give or take. It's a guess, so don't hold me to it. Okay, we're going to go ahead and we're going to move on to the next one. The next one is 19, and we are revolving about x equals 5. So it's got a vertical axis of rotation this time. We're looking at y equals 0, y equals x, y equals 4, and x equals 5. Alrighty, so we're going to try to graph this. Let's just see, we've got a line going up like this. My y equals 0 goes across like so. We have y equaling 4. It's going to cut it right here and here. Oh, it's actually cutting it a little bit lower, right there. So we're going from 0, and this is going up to 4. We're rotating it around the axis. X equals 5. That's right here. Here's my representative rectangle. Let's find our points. Now remember, we've got a big R and a little r. That's different from the representative rectangle. These 2 points right here are both the same at 5, comma y. This point right here, actually it looks like it's the same line, so we're looking at the washer method, or the disk method, excuse me. I'm just reassessing. Beware, when you draw a graph that's incorrect, correct it. Just means we have an upper region. We're doing the disk method. So this is my y, comma y. So I have my right is 5 minus y. So this r of x, r of y, excuse me, is 5 minus y, pi, integration, 0 to 4 of 5 minus y, the quantity squared, dy, 25 minus 10y plus y squared. 0 to 4 multiplied by pi. (25y minus 5y squared plus 1/3 y cubed from 0 to 4 multiplied by pi. And now I'm going to have to figure out what this is. 4, that's 100. 16, that's minus 80, plus 64 thirds. And that's going to give me 20 plus 64 thirds. That's 124 thirds multiplied by pi. And my answer is 124 thirds. Let's go ahead and move on. We're now going to move to number 21. Number 21 gives us x equals y squared. We also have x equal to 4. I'm just going to go ahead and graph this. Let's see. So our graph goes up like this, cuts across here. We're rotating around, x equals 5. So it's going to be, this is a washer method. Big R, little r, 5, y. This one is 4y. And this one is, and I'm just making sure I don't mess up. Let's see, let's go from 0 up here. And this intersection 4 is the x, so this would be 2. So this is 4 comma 2. And I'm going to integrate from 0 to 2, and I'm going to double my volume. So 2 pi integrated 0 to 2 for my upper. Now notice the big R right here is going to be 5 minus, 5 minus y squared. The quantity squared, there went my lights, minus, and when we take the difference of that, we have 1 squared dy. So we're going to have to FOIL this out. This is giving me, once again, 24 minus 10y to the second power plus y to the fourth power, 0 to 2, 2 pi out in front, dy. We're just going to slowly work our way through this. 24y minus 10 thirds y cubed plus 1/5 y to the fifth from 0 to 2 multiplied by 2 pi. So continuing, we're going to end up with 48 minus 80 thirds plus 32 fifths multiplied by 2 pi. And the 0 is going to just cancel. Let's see, this is 416/15 multiplied by 2 pi is 832/15 pi. And I hope I did that one correctly. Let's check it. Can't hurt. I'm just checking, people. Hornets, it doesn't hurt us to check our work. When you're not sure, do it. I mean, come on. What do we have to lose? 24 minus. Now, when you do this, make sure you're using x as opposed to y. That way you get the correct answer. In terms of x. And let's just make sure, what is 832 divided by 15 times pi? Yes, that is the correct answer. All righty. So that was number 21. We're now going to go ahead and move on to number 25. And we're doing numbers 25, 27, and 29. So just be aware of that, please. I have to turn the book. 25 is asking us to revolve the region bounded by the graph about the x-axis. So we're going to be graphing it about and doing about the x-axis. This will be the end of my part 3, and then we'll finish part 4 probably tomorrow. So just be aware. We have y equals 1 over x, y equals 0, x equaling 1, and x equaling 3. We're revolving about the x-axis. So I'm just going to try and get this piece. Let's see. We're going from 1 to 3. It's a reciprocal function. So 1 to 3 would put it somewhere around here. 1 to 3, rotating about the x-axis. And we're working with the washer method. So we can clearly see it as a washer method. We have x comma 1 over x. Down below we have x comma 0. So the big R of x, which is the only R we have, is 1 over x minus 0. So I have pi integration from 1 to 3, 1 over x, the quantity squared dx. This gives me negative pi 1 over x from 1 to 3. That's going to give me negative pi over 3 plus pi. And that would give me 3/3. So I end up with 2 pi over 3 as my answer. So my answer for number 25 is 2 pi over 3. Alrighty, so this is the end of my first video, or the third installment of this assignment. I'm going to finish the rest of the assignment tomorrow as we take a look at that 41 through 48 and then 72. Alrighty, if you have any questions, please remember to come in and see me. I am always available at lunch to help people. And if you liked this and felt it was helpful, please remember to click like. Otherwise, if you have suggestions, please make sure you give me a comment and let me know how I can improve. Thank you very much, everybody. Please be safe and be well. And we'll finish part 2 tomorrow, or part 4 tomorrow. Thank you. Bye-bye.